So this is the Algebra 2 mother function transformations. You are supposed to graph the mom function. Actually, you know what? Let's not even worry about that. Just graph this thing, okay? This is y equals 5, and I'm just going to go off the side. Y equals a constant is the mother function, and that's just a horizontal line. So y equals 5, we're going to be right here. We're going to draw a horizontal line. Ta-da! The domain of this line is left and right forever, negative infinity to infinity, and its range is just the singular y value of 5. Here we have y equals 2x plus 3. The mom function is y equals x, which is your slanted line. So we're going to take that slanted line, we're going to go up 3 units, we're going to put a point, and the slope has changed from 1 to 2, so we're going to rise 2 and run 1. And there you go. Runs left and right forever, that's negative infinity to infinity. The range, it falls forever and it rises forever, also negative infinity to infinity. Here we have two absolute values of x minus 1 plus 3. And again, you are expected to know your mom functions. The mom function is y equals absolute value of x, which is just a v. So the kid's going to look like a v. Here we have a right 1, and we have an up 3. So right 1, up 3. And here we have our initial slope of 2. So rise 2, run 1 in both directions. We had that conversation. And there the thing is. It does run left and right forever. You need to learn how to read a graph, not memorize. And its range has a low value of 3. And it rises on both sides of the tails for all of infinity. Next up is a square function. The mom function is something squared, which is your parabola. So the kid obviously looks like a parabola. Talk about your transformations. You've got a down 3. You have a right 1 because we always do opposite of what's inside. And here is your initial slope of 2. So down 3 and right 1 would put me about right here. There's an initial slope of 2, rise 2, run 1 both ways, and there is your parabola. Your domain is negative infinity to infinity, and your range is a low value of negative 3 raised to a high value of infinity. It's easy peasy, bruh. Number 5, we've got the cube function. The mom function is y equals x cubed. I missed the point there, but that's what she looks like, so the kid's going to look the same way. We have a left 1, down 3. And we have an initial slope. And again, remember, this is the initial slope of negative 2. So I'm going to fall 2 and run 1 both ways, and I did that backwards. I've got to fall 2 as I move right and rise 2 as I run left. Then I just redraw mom. Runs left and right forever, so negative infinity to infinity. Falls forever, rises forever, negative infinity to infinity. On 6, your mom function is y equals the square root of x, which is just your arm. Looks like that. It's a curve, not a straight line. What do we have here? We have a left 2, because opposite, and we have a down 4. And these are the same functions with different notation. We have an initial slope of 4. So left 2, down 4 is going to put me there. Initial slope of 4, rise 4, run 1, and then draw an arm. Now, this one's domain is going to be a little trickier for some. It has a low x value of negative 2, and then it runs right forever. Its range, we have a low y value of negative 4, and then we rise forever. Moving forward. Number 7, which is a little trickier. Maybe you remember doing some of these, maybe you remember missing them, I don't know. But I'm requiring you to do a little factoring and then doing some cubic rooting on this one. I noticed that both these terms are divisible by 27, so I can think of this as the cubic root of 27 times x minus 3, and on the outside still a minus 2. And I know that the cubic root of 27 is 3, so I put the 3 on the outside. And that's what this thing looks like. Now, mom for this one is a lot like cubed, except it's long. Because the mom function is y equals x to the 1/3, or cubic root of x, whatever you want to think of it as. I have a down 2 and a right 3, down 2, right 3, and I have an initial slope of 3, rise 3, run 1, fall 3, run 1. And this one is long. I think it was Cameron. Domain is going to be the same as mom, runs left forever, runs right forever. Range is the same as mom, falls forever, rises forever. And the last one is, before you do your end behavior, is x equals -3. Its mom function is x equals a constant, which is just a vertical line. So this one has a vertical line at -3. This one's going to be missed by a lot of kids. I know this from past experience. Maybe y'all will prove me wrong. Its domain is the singular x value of -3. Its range, it falls forever and it rises forever. And then you've got your end behavior, which these are basically just memorization. X to the even starts high and ends high. Your verbal description, which is something that a lot of kids just don't seem to want to do. I guess they don't like writing. But it's as x approaches, which is just an arrow, -infinity, y approaches positive infinity. And, which and a lot of you leave this off, you don't have to write the word and, as x approaches positive infinity, y is also approaching positive infinity. There we go. X to the odd. X to the odd begins its day low. It has a good time and ends its day high. Now, as x runs left towards -infinity, the y value falls towards -infinity. And as x moves right towards infinity, the y value also moves up towards infinity. 2 to go. -x to the even is just a downer. Starts low, ends low. And here, as x approaches -infinity, you can see the y value is also approaching -infinity. And as x approaches the right, positive infinity, the y value is approaching -infinity. And the last one, and that can be done recording for today, is -x to the odd. -x to the odd is going to start high and end low. So it starts off in a good mood and a lot of things go wrong, and it just ends up unhappy. But as x runs left towards -infinity, the y value rises to infinity. And as x approaches positive infinity, the y value falls to -infinity. And that quiz is going to be Friday. So have fun with that.